Hello techies, welcome to another quick 5-minute learning video. In this video, let's try to compare and identify the similarities and differences between traditional client-server application and a machine learning application. I hope this video will be useful for you. Let's get started. First, let's break down the comparison between a traditional three-tier architecture project and a machine learning project. This will help you understand the unique aspects of each and how they are structured and implemented. Client-server project structure. A traditional three-tier architecture typically includes three layers. Presentation layer. This is the user interface that interacts with the end users. This can be a web or a mobile application. The technologies used are typically HTML, React, Angular, etc. And business logic layer. The backend services that process user inputs, apply business rules, and interact with the data layer. Technologies used are typically .NET, Java, Python, etc. And the last one, data layer. The database or data storage, where the application's data is stored and managed. Technologies used are Oracle, Microsoft's SQL Server, MongoDB, etc. Machine learning project structure. A machine learning project has a different structure focusing on data processing, model training, and deployment. Key components include data collection, which is gathering the data to be used for training the ML model, and data processing, cleaning the data and also handling missing values is called processing. This phase is important because the processed data will be used further and impacts the prediction. Feature engineering, transforming raw data into features that can be used by the ML model. Model training, selecting and training the ML model using the prepared data. Model evaluation, assessing the performance of the trained model using various metrics. Model deployment, deploying the model to any non-production or production environment where it can make predictions on new data. Monitoring and maintenance, continuously monitoring the model's performance and updating it as needed. These are the main 7 stages which are part of the machine learning project structure. Let's look at the comparison of these two project types. Let's see the similarities first. There are two things which are very similar in these two project structures. One is the layered approach. Both follow a structured approach with distinct phases or layers. Number 2, it is data handling. Both require handling and managing data efficiently. These are the two similarities between a traditional three-tier application versus a machine learning project. Now let's look at the differences between these two project structures. Let's take the objective. Traditional projects focus on CRUD operations and business logic, while ML projects focus on prediction and pattern recognition. Number 2, processing. Traditional projects process user inputs and apply business logic, whereas ML projects involve complex data processing and model training. Deployment. In traditional projects, deployment involves the application and database. In ML projects, deployment includes the model and sometimes a separate service for predictions. In maintenance, traditional projects require regular updates and bug fixes. ML projects require model retraining and performance monitoring. Let's outline the different roles typically involved in both three-tier application projects and machine learning projects. While there is some overlap, especially in roles related to software engineering, each type of project also has unique roles specific to its requirements. Roles in a three-tier application project. Developer, responsible for UI, business logic development. DevOps engineer, responsible for CI/CD pipeline engineering. Database administrator manages the data layer, ensuring data integrity, performance, and security, works with SQL or NoSQL databases. And QA engineer ensures the quality of the application through testing, identifying bugs, and verifying the fixes. Now let's look at the roles in machine learning project. Data scientist responsibilities analyzes and interprets complex data, develops ML models, performs feature engineering and evaluates model performance. The skills required are statistics, machine learning algorithms, data wrangling, Python or data visualization. Data engineer or ML engineer. Responsibilities designs, constructs, and maintains data pipelines and architectures to ensure efficient data flow and access. Also implements and optimizes ML models, handles model deployment and scalability, integrates models into production system. Skills required are ETL processes, big data technologies like Hadoop, Spark, SQL and NoSQL databases, and ML frameworks like TensorFlow, PyTorch, and model deployments like Docker, Kubernetes. Research scientist conducts advanced research to develop new algorithms and improve existing models, often working on cutting edge platforms. Skills required are deep learning, algorithm development, research methodologies, publishing in scientific journals. And finally, the ML ops engineer focuses on deploying, monitoring, and maintaining ML models in production, ensuring continuous integration and delivery for ML pipelines. Skills required are ML model deployment, cloud services, CI/CD for ML, monitoring tools, etc. In summary, while traditional three-tier architecture projects and ML projects share a structured approach, their focus and implementation details differ significantly. Traditional projects emphasize user interaction and business logic, whereas ML projects center on data-driven predictions and continuous model improvements. Understanding these differences is key to successfully managing and implementing each type of project. While traditional three-tier application projects and ML projects share common roles such as project managers, the roles in ML projects are more specialized towards data and model management. ML projects require expertise in data science, machine learning, and data engineering, whereas traditional projects focus more on the front end and back end development, database management, and system integration. Understanding these roles is crucial for assembling the right team for each type of project.